I guess reflecting on action and what that means to an architect, there's a bit of a dilemma, or at least a paradox going on, where what we do as architects is draw, but perhaps the real action actually is on site with building. What we're drawing for is to make buildings. We create space using geometry, light, and materials. And if we think about what drawing looks like, it looks perhaps something a little more like this. Maybe this guy looks like he's having a bit of fun at least. I particularly like the vertical keyboard there. At worst, you know, it could be like this. But sort of thinking about how that relates to action, it seems that we're, as architects, moving further and further away from being on site, from that direct relationship. Okay, so in this slide we see a ceiling plan of a medieval Gothic cathedral. And what's interesting here is that rather than drawing as we might expect drawings like this, they actually, to actually produce these amazing spaces, they were the master builders rather than architects were right in the thick of the action. So they had drawings like this. You can see in the middle slide here that they're interested not so much in representing what they were trying to draw, but here they're actually describing a method, a procedure for, in a sense, computing where exactly that middle line of arches should end up in space. And it was a much more tactile one-to-one relationship with materials and form. This is a tracing room floor where they would trace out patterns to inscribe on stone that would then be cut out. So with ARMA, which is Architectural Research Material Applications, which I co-founded just 2 years ago now, we were interested in taking the same sort of understanding of or desire to get closer to the action, and express that desire through what we saw as a rapidly growing, actually exploding opportunity of computation and how it relates to things, devices. This next machine, that's a laser cutter, and this is a turret punch. So these machines will directly work from a computer file and take those instructions and transfer them directly into material. So we use this sort of technology to make bits of buildings. So here you can see a whole bunch of prefabricated panels that go together to make, this is an interior at UTS actually, just down the road. And you know, we work directly, we have this really direct relationship between what we draw and what gets produced. And I guess this is another example. Again, a CNC machine. This one uses a cutter like this to drag through a material. So in this case, a sheet of corian. And these different panels go together, again, to make a wall like this. You know, always interested in geometry, in light, and in creating form. And I guess here is a machine that's only a little more complex than the previous ones I showed you, and this is currently working at the University of Sydney with a robot like this, and I guess that's in the architecture faculty, and we're used to seeing robots like this in automotive, the automotive process, or in shipbuilding or in aerospace. Next slide. But I guess building is a little more unorganized. That's not to say that this is some people in Zurich at ETH doing research with a robot arm, actually using that to place individual bricks. And what's interesting here is that we get into this concept of mass customization. And what we're talking about here, if I go to the next slide, you see here a typical normal brick, which is plainly uninteresting perhaps, but by understanding it and using computation and this kind of direct control of a process, we're actually able to intervene and make something a whole lot more interesting. And we're used to this as consumers with something like this. Nike ID is a website where a consumer can jump on and completely customize in this case a sneaker, to make it however they like. And some other people doing similar work in this field, this is a group called Nervous System, where they use these same ideas of computational design and then a direct connection to a process of making, in this case 3D printing, to allow a user to design interactively their own unique piece of jewelry. Even with these examples of mass customization, there's a big arrow going down the page here. It goes from a producer to the consumer. And on the next slide, it's actually the Person of the Year from 2006. It's a rather interesting choice. It's of course you, or kind of YouTube. And then again in 2010, next slide, we have Mark Zuckerberg and of course Facebook. So we're really used to this idea of actually this inversion of production, where as consumers we can now, where we used to be consumers of media, we are now freely able to very democratically create media using these kind of platforms, Facebook, YouTube, and Twitter. So you see this kind of change in relationship where the producer and the consumer are actually the same person. And what's interesting for me is this is kind of this direct relationship to production, which I just showed you in those previous slides, is now becoming sort of much more accessible. And so this is Shapeways as an example of an organization taking some of this technology, 3D printing in this case, and putting it on a sort of open source, freely accessible platform on the internet. So Shapeways takes the Star Trek replicator, just an expensive 3D printer like this, an industrial quality but very expensive machine, or like this one, and puts it, makes it accessible to us all through a website. So anyone can log on, upload, or actually design on there, and it does actually make some of this technology accessible to everyone. And so it can be even more direct and pure than this. This is an example of an open source hardware and software project where it's a 3D printer that you can make all the bits for yourself. It's so easy to make, in fact, that even your, next slide, even your cat can do it. Next slide. And so if we just go through these next couple of slides, they're all examples of 3D printers which are made really accessible. So really low-cost 3D printers that are accessible to a lot of people. So again, the interesting idea here is that not only is this an e-commerce website, but it also takes some of these ideas that I guess came from something like YouTube, and this idea of sharing and open source and collaboration. Here you can see sort of a little connector piece that allows you to connect all different kinds of children's construction play sets together, and it makes all those sort of freely accessible and available. And of course, it really is open to anything. So here we have Sad Keanu, sort of internet meme, that then some enterprising individual uploaded a 3D model of Sad Keanu, and then sort of got this second wind to the meme, where not only were people photoshopping the actual photo, but then they were 3D printing Sad Keanu and then dropping him into all kinds of places. Yeah. Okay, thanks a lot.